Hi everyone, Mr. Morrissey. Um, let's see here. Today we're looking at square roots. There's a lot to look at here, but I'm going to key you into what I've written in my own words, which I think is most important. It says, if in the course of solving the problem, I take the square root of a number, such as solving for x squared equals 100, then there are two solutions, plus or minus 10. But something like the square root of 100 has only one value, 10. And that's because the square root's already there. So today our objective is to solve equations by taking square roots or simplifying square roots, but basically dealing with square roots. And I think what I just put in the yellow box is definitely the hardest thing for people to remember or, wrap their brain around, so to speak. So if you take a square root, if you square root both sides, you need to do the plus or minus. Very important. But if you already have square root of 100, then that's just going to be 10. Let's see. You know that if inside the radical is a negative, then that's going to be an imaginary number, which is something we are going to do in a future lesson. And then there's going to be some problems. I just mentioned simplifying radicals right here, knowing that if you have square root of a times b, you can break that into the square root of a times the square root of b. And in the same vein, square root of a over b is the same thing as the square root of a divided by the square root of b. Ooh, here's something that's important. Rationalizing the denominator means when you take the radical out of the denominator by multiplying the numerator and the denominator by the conjugate. We will be talking about that today. It says here the conjugate of a plus b is a minus b, and square root of b is special. If you just had square root of b, you would just multiply by square root of b. Please don't forget the plus or minus. SAT loves to solve equations and then have the solution be the minus equation. So please don't forget about the poor little plus or minus. Let's see. You can read these sets of notes over, hit pause, and see what makes sense. You can put in questions into the video summarizer. And let's go right to number 1. So rationalize a divided by b plus square root c. Okay, to do this, let me get my favorite color, although navy blue is my favorite color. We need to multiply by the conjugate. That's what the note suggests to do. The conjugate is b minus root c. If you multiply the top by b minus root c and the bottom, you are going to get rid of any vestige of a radical in the denominator. So let's do some expanding here. So the numerator is just that, and the denominator, well, b times b is b squared. You guys notice that's a difference of squares, so the middle terms are going to cancel. But if you don't notice that, let's write them out. Okay? So the middle terms cancel. They're gone. We get ab minus a squared root c over b squared minus c. I'm going to put a box around that. If you guys notice, the square root of c in the denominator that we started with is gonzo. We get ab minus a root c over b squared minus c. Intimidating problem to start with, but it's all with a, b, and c with variables. So this really tests you understand how to find or how to rationalize a denominator. Okay, let's go to question 2. Question 2 is actually going to be one where we're taking a square root. So first step, multiply by 5. Second lunch. You guys can go to lunch if you want. So I just multiplied by 5. And now, look, you've isolated the square root term. So at this point, you're going to square root both sides. Okay? So now you notice I didn't put in the plus or minus. Since I'm introducing the plus or minus, I'm going to put it in a different color. You need to remember the plus or minus. So this is going to simplify. Now, square root of 35. Can that be simplified? Don't know off the top of my head. So 35, I'm going to divide by some prime numbers, 5 and 7. Those are both prime numbers. We can't simplify root 35. The only thing we can do is say this. Negative 3 plus or minus square root of 35. Now look, let's say you're not confident. Let's check one of these. So let's check our work. It's always a good habit. Let's just take one of them. So let's take negative 3 plus root 35. That's x. Well, this x, we're adding 3 to it, putting a big parentheses around it and squaring it, and then multiplying it by invisible 1 over 5. Does that question mark equal 7? I don't know about you, but that looks intimidating. But you see that the 3 and the negative 3 cancel. So you get 1/5 root 35 squared equals question mark 7. Square root and squared cancels, so we get 35 over 5. That does equal 7. Check. Key thing in this problem was isolating the square root term, or the squared term, I should say, and then honestly, guys, the plus or minus. Now the next one, I could be like, oh, I didn't know. You could be like, oh, I don't know. Is this 3 questions? Is this 1 question? It's 3 questions. Let's start with the easiest first, square root of 27. So square root of 27, I'm going to suggest you divide by 3. So we get 3 times 3 times 3. Remember on the notes it said you can break up the numbers inside of the radical. So honestly, if you wanted to call this 9 times 3, you know the square root of 9 is 3. So we get 3 root 3. Done. Now we'll go to the second easiest one, the 243. So 243, I see that, so that was 3 minutes. 24 is divisible by 3, and so is 3, so 3, 81. Eventually, I think you should know 81 is 9 times, or you should know 81 is 9 times 9, and that 3 to the 4th is 81. So this is the square root of 243 equals the square root of 3 to the 5th. Because here, guys, this is 9 times 9, which is 3 times 3 times 3 times 3, plus the original 3 you divided by. That's 3 to the 5th. So if you needed to break this out, you could write it like this. Okay? And then you can see you have a group of 3 here and a group of 3 here. That's going to be 9 root 3. Okay, last one. Last one's hard. The last one, I'm going to have to go really slow here. On the outside, you have 3 times 5, that's 15. On the inside, we have 24 times 10. Right, make sure I wrote that right. Looks good. So let's just break this down ourselves. So 24 is 3 times 8. 10 is 2 times 5. We get 3. Now 8 is 2 times 2 times 2. Okay? So now I've just broken down all of the numbers pretty quickly. I can notice that here, 2 times 2 times 2 times 2 is 16, and the square root of 16 is 4. So I get 3 times 5 times the square root of 16. Square root of 16 is 4. So I'm going to bring a 4 on the outside. And I get 60 root 15. So I'm assuming some people have done somewhat, some algebra radical simplification. But if you haven't, I can see how this green problem would be very intimidating. So we're at different levels in different classes. So just know that we will practice simplifying radicals. Um, let's see. The next one, oh my gosh, root 2 minus root 1 divided by root 1 plus root 2. Okay, let's look for the conjugate. So the conjugate here is going to be, let's call the conjugate root 1 minus root 2, which you might be saying, well, isn't it the same thing as 1? So let's simplify. 2 minus root 2 over, root 2 minus 1 divided by 1 plus root 2. Let's multiply by 1 minus root 2 and 1 minus root 2. Okay? Now, we're multiplying by 1 minus root 2 on the top and the bottom. If you do the same thing at the top and the bottom, nothing's changed. So let's FOIL here. Root 2 times 1, and then minus 2, minus 1, plus root 2, over. Remember, the middle terms cancel because you've set up a difference of squares. So 1 minus 2. So I'm going to double check my work because this is sort of tricky. Okay, I think it looks good. So I get 2 root 2 minus 3 over negative 1. So now look, you got to be good with the negatives. You could leave your answer like that, but another form of your answer, you usually get rid of the 1, the invisible 1. So when you divide each term by negative 1, you just switch the sign. Oops. Get the eraser. So we're going to get 3 minus 2 root 2. That's the answer. Now the denominator no longer has a root 2 in it or a root 1, and we get 3 minus root 2. How about this? I'll promise to end on easy questions, because some of these have been sort of tough. The key thing here was multiplying by the conjugate. The conjugate was 1 minus root 2. Okay, 3 minus 2 root 2 is the same thing as this crazy mess that we started with. The only difference is there's no longer a root 2 in the denominator. Okay, now for some easier problems. You want to isolate the, say, x minus a squared term. So divide by 2. Now square root both sides. We're going to get, remember you have to do the plus or minus 0, but plus or minus 0 really just is 0. So we get one solution, negative 1. If you wanted to test that, let's see, 2, negative 1 plus 1 squared equals question mark 0. 2, 0 squared equals question mark 0, and that's 0. Perfect. Okay. That was just a solve an equation. I think it can be a little bit tricky because of that equals 0. Last question. So x squared minus 5 equals 0. So here's one with actual numbers, and x squared is 5. Now square root x squared. You're introducing the square root. You need plus or minus square root of 5. So we get x equals plus or minus square root of 5. Let's just make sure those are correct. Let's take negative square root of 5, square it, minus 5. Does that equal question mark 0? And it does. 5 minus 5 is 0. The square root of 5 would give you the same thing. So if I had to recap here, the objective was to solve Actually, I better go back to see. It's not on my paper here. Solve quadratic equations by taking square roots. And I would say a also just as important objective was this idea of rationalizing denominators, because we just did two pretty tough problems, at least, that had to rationalize denominators. Okay. I hope everyone's having a great day. Bye, guys.